Dear colleagues, I'm Dr. Shoubin Zhou from China University of Geosciences in Beijing. I'm really honored to have the 2021 Founders Scholarship and the opportunity to give this presentation. The topic of my presentation is tree stumps as bioindicators of metallic pollution caused by road dust resuspension and deposition in mining areas. The elements associated with buried mineral deposits may migrate upward and display the high geochemical anomalies in surface soils. And this type of geochemical anomalies may provide insights into mineral prospecting and exploration. However, during mining activities, many elements, for example, heavy metals, may enter the environment, though unwillingly, and we often define these elements as pollution. These polluted elements may also induce some high geochemical anomalies. The two types of geochemical anomalies may mix and display as overlapping geochemical anomalies. To decompose the overlapping geochemical anomalies is not only the focus for geoscientists, like finding new deposits, but also for environmental scientists, because to identify the overlapping geochemical anomalies may help to control the distribution of polluted elements and to distinguish between polluted areas and unpolluted areas. Soils, sediments, and waters are some common sampling media in geochemical mapping. But soil in mining areas may contain both types of anomalies and sometimes can be confusing, whereas many mathematical geoscientists proposed many theories or models to decompose the overlapping geochemical anomalies. Well, a good question here is, can we find some other better sampling media? Human activities often accompany with deforestation, especially in developing countries. Therefore, tree stumps are very common in forests in mining areas, well, at least in northeastern China. Compared with soils, tree stumps can be a direct receiver of dust pollution, and meanwhile, it can eliminate the potential disturbance caused by inherent, or we can say the primary geochemical anomalies induced by buried deposits. It seems like tree stumps may be a good bioindicator of dust pollution. In a field study in the Bailin copper zinc deposit, Acheng District, Harbin City, China, road dust resuspension triggered by traffic could be obviously observed. Well, a good question is how far the road dust could travel from the road. For studying the distribution of polluted elements in the forest close to the road, the cut surface of tree stumps was analyzed using a PXRF analyzer over here. And the soils in each location also underwent in situ PXRF analysis. As shown in Fig 3, the Bailin copper zinc deposit is in the west over here. The pink line represents the road and the blue line represents a stream passing by the deposit. And the green dots represents the in situ PXRF measurement sites. A total of 230 tree stumps and soils in each site underwent in situ PXRF analysis. Fig 4 left display arsenic distribution in the cut surface of tree stumps, and the right displays arsenic distribution in soil in each site. The two distribution patterns are highly resemble. Arsenic concentrations are highest in the area nearest to the road and generally decrease with increasing distance to the road. Zinc distributions in the cut surface of tree stumps and in soils in the left in each location are quite similar to those for arsenic. Zinc concentrations are also highest in the area nearest to the road and generally decrease with increasing distance to the road. Well, for mathematical geoscientists, we are more curious about numbers. And Fig 6a and Fig 6b illustrate the relationship between distance to the road and arsenic concentrations in tree stumps and arsenic concentrations in soils. And Fig 6c and Fig 6d illustrate the relationship between the distance to the road and zinc concentrations in the cut surface of tree stumps and in soils. Arsenic and zinc concentrations generally decrease with increasing distance to the road, conforming to a power law distribution. The exponent of the power law function for arsenic or here are much lower than those for zinc. This phenomenon should associate with the physical and chemical composition of road dust. Presumably, the portion containing higher degree of arsenic probably is heavier and could not travel a long distance. Therefore, the concentration dropped dramatically. And some further study should investigate the particle size distribution of the road dust and the chemical composition of each portion. Besides using a PXRF analyzer, this work also used a Bruker M6 micro XRF analyzer, so here, to scan the board vertically cut from the tree stumps collected in the study area. As shown in Fig 8a, Object 2 area is the cut surface, the upper surface of the tree stump. And Object 1 was selected as background for comparison. As shown in Fig 8d, the brighter area over here indicates higher zinc concentrations. It can be observed that zinc mainly concentrates in the cut surface of the tree stumps, which means the road dust have deposited in the cut surface and caused the high zinc concentrations. Well, from Fig 8c, the black solid line over here represents the X-ray spectrum of Object 2, which is the cut surface of the tree stump, and the gray area over here represents the background, which is Object 1. And we can also find that arsenic and zinc has an obvious peak in the X-ray spectrums. And this also indicates that the source of contamination was road dust deposition. Therefore, tree stumps should be a good bioindicator for road dust contamination because it can eliminate the disturbance caused by the inherent geochemical anomalies caused by the buried deposits. Okay, that's all for my presentation. And I would like to thank the International Association for Mathematical Geosciences for granting me the 2021 Founders Scholarship and IMG Natural Resources Research Student Research Grant. I would like to especially thank the president of IMG, the Peter Dord, Regina Bogart for their hard work. And I also would like to thank the past president, Jennifer McKinney, and Professor Yuri Mueller and other IMG members. And I have acknowledged all IMG grants in my recent publications. Thank you all. Thank you.
Thank you very much. Okay. Do we have any questions for Shoubin? So can I then ask, when you look at the data you showed us how you analyzed the tree stumps, and you also looked at the background. Now, how are you going to use that to separate the two?
I
And
mean,
how are you going
separate
to deal with the overlap? How are you going to deal with that? I mean, we know what the contamination from the road is because of the tree stumps.
Mhm.
So what are you going to do with that information?
Okay, so this kind of, I mean, okay, so from the power law distribution, we can generally know the distribution of these elements, and we're gonna know like how far the polluted the polluted elements may migrate.
Mhm.
And well, this can be much useful in other areas in which that with variable geochemical characters in other mining areas. It can be some useful tool, or it can be a useful media for like environmental assessment. And this is how I use this data for.
Thanks. Any other questions? Just looking at the chat.
Were the
Okay.
trees cut
Yeah,
down specific mining? Could you do this instead of on leaves? Can you do long-term exposure? Well, it's a genuine. Oh, well, this is a very good question. The trees were cut down, was not cut down specifically for the mining, but during the mining activities, many like local inhabitants gonna cut the trees, and the tree stumps gonna exposed into the air, and the dust can deposit in there. And could you do this in situ analysis on leaves? Yes, we can do this kind of analysis on leaves. However, the elemental concentrations on leaves may also decided by the weather. If it's raining yesterday and you analysis today, so the concentration won't be high. But in tree stumps are much different because it is a receiver, and the polluted particles cannot easily like may not easily to drop. And can you invest long-term exposure? I think the reason why I study the tree stumps is because I want to study a long-term exposure. And because the tree stumps can be can sustain, can be there for a really long time, so it just can be a good receiver to accept the large amounts of like road dust. Okay, thank you for your question. Does age of oh well, yes. Another very good question. I want to discuss this in my presentation. Does the age of the tree affect the something how to determine the tree after, before, or mining? Well, yes, there are some new trees, some trees that cut. We can see they cut from like not far from now, like for 1 or 2, 3 years. But because we have collected enough trees, we have done enough analysis for like 231 trees, and some trees may be cut from like several years, and several maybe, and some other trees may be cut from like several months. But statistically, it's gonna behave some. It will behave a distribution like close to the road high and not close to the road not high. And I'm gonna show you. I'm gonna show you the question. Okay, wait a second. It's over here. As we can see over here, and the tree over here, you can see here it is blue because this tree must have cut recently. So the arsenic concentrations is not high, but the arsenic concentration in soils is really high. And similar for zinc, and this tree similar. This tree must have been cut like recently, and the zinc concentrations is not high, but soils over here is really high. And this very good question. Any more questions?
No, it doesn't look like it for the time being. So, no, here we go. Is there a way to get a time series from a single tree?
I'm sorry. Okay, is there a way to get a time series for a single? I doubt it because because the local inhabitants just cut the trees randomly. It's really hard to define like when the tree has been cut. Well, this could be a question, but if you have a lot of trees, and statistically, and this kind of trend can also be observed, but well, it is kind of hard to get a time series for a single tree.
Yeah, but you could be resampling that tree.
What do you mean?
You know, you could be resampling. I mean, you could be sampling the tree at the particular trees at regular time intervals.
Yes, yes, that could be done, but probably like for years, like in this year, gonna analysis one time, and we have the spatial data. And next time come back again and analysis this again. Well, it can be done, but sometimes it's not that easy because the local people may cut down new trees. Well,
Yeah,
probably gonna try to do this one. It's a good suggestion. I think so.
Yep. Gil says thanks. Wang Chengbing says yes, thanks.
Okay.
So, yeah, thank you very much, Shoubin, for a very interesting talk.